Good morning, everybody. And hopefully you're ready for another exciting morning of chemistry with your host, me, Dr. White. Humidity. Never can do anything good with my hair when it's high humidity. Anyways, all right, important things. One, I've caught up on grading labs, and if you look in Blackboard, you can see the points for your different labs. Remember, every lab has a maximum of 11, 10 plus 1 points. Generally, if you miss one question, I'll take off a point per question. It's the way I do it. If you mess up the data totally, I'll take off a point. Most of you are getting 10s and 11s, which are A's on lab, which are should be. Now, over the weekend, I finally had time. If you haven't figured out, this is the first time we've used Labster. And I did the 2 labs you're going to be doing this week. The first one, all right, just do as much as you can, answer at least one question, and you'll get full credit. And the second one, well, everybody understand? And it is. So between now and Wednesday, I'll be writing my own lab for that. Take a look at the Labster one, but I'll write a better one. I already know how to do that. And let me remind you, I changed the syllabus. Test number 2, which was originally scheduled for this Thursday, will be a week from this Thursday. And I feel much better because it's better for you. Trust me, I can get a perfect score on it. Why should I write it? But let's go into some chemistry. I'd like to all remind you, and this I'll put, and I'll put some more for important information in test 2. You should know 1 mole of an element equals Avogadro's number, 6.02 times 10 to the 23rd atoms of that element. 1 mole of a compound equals 6.02 times 10 to the 23rd molecules of that compound. Now, also 1 mole of an element equals the atomic weight of that element in grams. You can use other ones too, but for this class, I'm going to stick for grams. And 1 mole of a compound equals the molecular weight of that compound in grams. And finally, the molecular weight of a compound is the sum of all atomic weights. This I'll post soon. It's in, if you look at chapter 8, it's in the beginning of chapter 8, where I have it in yellow that I should have deleted, but I didn't. So it's chapter 6 and chapter 8 repeated. But these are extremely important. And if you notice, I was practicing with my tablet. In about a half hour, it'll still look bad, but it's looking better. You should know 1 mole of an element equals Avogadro's number that in atoms of that element. 1 mole of a compound equals Avogadro's number in molecules. 1 mole of an element equals the atomic weight in grams of that element. And 1 mole of a compound is equal to the molecular weight of that compound in grams. And in case you forgot, the molecular weight, also known as molecular mass, but I use molecular weight, is the sum of all atomic weights. And the atomic weight is on the periodic table. Remember, for my class, use all atomic weights, the 3 significant figures. Hang in there. I just remembered I never opened up my periodic table. Remember the periodic table, the number underneath and not the one I'm giving you, this green one, the number underneath, and it usually always is on any periodic table, is the atomic weight. Remember, for my test, it will say, please round all atomic weights to 3 significant figures. So for hydrogen, that'd be 1.01. All right. Let's do a problem. And this might be higher than 5 points. It might be anywhere 6 to 8 even. All right. First of all, it's Monday, and it's time for me to call upon my thumbs up people. Can you see the problem on there? Thank you, thumbs up people. I gotta have t-shirts made up for you guys. All right, I'm gonna do this one, and then I'll let you have fun doing it. I think my Freudian slip was showing. All right, first thing you have to do is, what are you being asked to find? And that's how many moles of water. Remember, Dr. White uses the old way of spelling moles with an E. In a lot of texts nowadays, in the last 10, 15 years, they dropped the E. I don't like that. I'm old fashioned that way. All right, next, what are you given? You're given how many grams of water? Now, there's only one number we can start with, and it's important to put the units and the molecule. And if I can convert this with some magic ratio, what units do I want my answer to be in? And that's moles of water. I wouldn't do this in a class, but I can do it online. Guess what time it is? It's time to use your good buddy and your good friend, unit analysis. Have I lost my mind? Yeah, but that's beside the point. Use unit analysis. Remember, I'm going for the Guinness Book of World Record for saying it the most times during a summer class. Use your good buddy, your good friend, unit analysis. And how do you do that? Whatever unit you're trying to get to, goes on top of the ratio. Oh, by the way, I'm not charging extra for color. Whatever units you're trying to get rid of goes underneath the ratio. So therefore, moles, water go here. Grams, which I'm trying to get rid of, water goes here. Now, where do we get that information? Where do we find a ratio or dealing with moles of water and grams of water? Let me just remind you, when one thing equals another, you can have two ratios. C over D and D over C, which brings us back to this. If we were in the classroom, I'd have this on the board, but we're not, so I'm going to switch back and forth. Where do we get this? From this right here. 1 mole of a compound equals the molecular weight in grams of that compound, and the molecular weight of that compound equals the sum of all atomic weights. Sorry about that. I had two blank. Let me just clean up for a second. All right, I think I just blew away my problem. Hold on, I apologize. Let's do this again. I deleted the wrong thing. That's what happens when you have too many things opened up. Okay. I don't know if I'm using the right number. Thank you. All right, where do we get these numbers? 1 mole equals the molecular weight of water. Molecular weight of water is the sum of all atomic weights. There's 2 hydrogen, 1 oxygen. If you go to your periodic table to 3 significant figures, the atomic weight of hydrogen is 101. For oxygen, 3 significant figures, 16.0. We've already done this. Do the math. Add them up. Remember, you get the same number of significant figures past the decimal as the number that has the fewest. 2, 1, round this off to 1, keep this. So the molecular weight of water is 18.0 grams. And before I pick up my calculator, I'll look, do my units are right in my final answer? Now, anything divided by itself equals 1. Therefore, grams of water divided by grams of water is 1, cancels out. I'm left with the right units, and now I can go pick up my calculator and do the math. Right now, if we were in a classroom, you'd see me opening up and setting up my spreadsheet. And now do the math, and notice I get this number. And if you go back, and we will, on my test, we'll say, please use proper significant figures for all calculated answers. You notice this one has 4 significant figures. This is an exact number, which does not play a role. The 18.0 is 3 significant figures. When you do multiplication division, you get the same number of significant figures in your answer as the number that you're using as the least. I think you'll all agree 4 is less than 3. So let's go back. And I'll let you round that off to 3 significant figures. Y, S, and T. Oh, that's good. And the answer is times up at 10.5 moles. Keep the 1, keep the 0. It's significant because it's confined. Keep the 5. 3 is the number you use to round off. It's 4 or less. You drop everything since it's past the decimal. Keep this, and the correct answer would be 10.5. I just learned something I don't, well, I'm not going to give it away. And that's how you do it. Oh, this was fun. Let's do another one. One of the bad things about the stylus is it has some buttons on it that I keep on pressing when I don't want to. And sometime in your future, if you see this, might say 6 points. How many grams of ammonia are 8.326 moles of ammonia? Since you don't have a periodic table, I'll help you out. The atomic weight of ammonia is this, not ammonia, nitrogen. Atomic weight of hydrogen is this. Why don't you try doing this one on your own? Remember, one mole of a compound equals the molecular weight of a compound, and the molecular weight equals sum of all atomic weights. Go. Remember to use your good friend, your good buddy, unit analysis. In teaching, this is called fading prompts. Oh, it makes me so happy seeing all of you work on your problem. All right, does anybody need more time? Thumbs up if you're done, or clap. If you don't have a calculator, as long as you can set it up, that's good. I'll give you another minute while I have some more tea. All right, let's do this. Let me check to make sure I got the right. Okay. All right. So the question is, first of all, what are you trying to find? How many grams of ammonia? What are you given? There's 8.32. Well, I keep on hitting that button. This is what you're given. You also, well, we'll get to that in a second. Therefore, if I look at this, this is the only number I have to start with. And if there were some magic conversion ratio that I could convert this number to my answer, what units do I want my answer in? This is why you take the time to figure out what you're trying to find. Grams of ammonia. And now it's time to use your good buddy, your good friend, unit analysis. And unit analysis, look out, I'm going Technicolor on you. Unit analysis is where whatever you're trying to get to, you put on top of the ratio, those units, and whatever you're trying to get rid of, you put underneath. That's not hard. So on top, I'll have grams of ammonia. Down here, I'll have moles of ammonia. Now, where do I find the numbers to put in this ratio? I look over here and say 1 mole of a compound equals its molecular weight, and the molecular weight is the sum of all atomic weights. And if I come over here, NH3 has 1 nitrogen and 3 hydrogen. Each nitrogen is 14.0. Each hydrogen, the 3 significant figures, is 101. Add this together, you get this number. Notice this has 1 past the decimal. This has 2, which is a smaller number. Hopefully you picked 1. Therefore, you round this off to 1 past the decimal. The stuff on the left, you ignore. Just past the decimal for addition. This is 1. This I used to round off. It's 4 or less. So 1 mole equals 17.0 grams, and that's where I get those numbers. Now, before I pick up my pen or my calculator, I look at my units cancel out. Moles divided by moles, remember A divided by A equals 1, cancels out. What am I left with? What I want. So I'm on the right path. While we're over here, notice this is 4 significant figures. This is 3 significant figures. This is an exact number that plays no role in the calculations. Going to my calculator. My calculator gives me this number, and I'm going to let you have a little fun more. Round that off to 3 significant figures while I steal some more tea. All right, let's take a look at this. I'm going to put it on the whiteboard, my board, I guess. And the number our calculator gives us oh, thank you. I made a mistake. Now, if I had done that on a test, thank you, Shahana. I hope I'm pronouncing your name right. If not, correct me after class. Let's go back. If you had made the mistake I just did, let's go back. That's the problem where I'm switching back and forth, and I have and this is a number. I'll let you round this one off to 3 significant figures. This one's a little easier. Time's up. Keep the 1, keep the 4, keep the 1, 5's round off. It's past the decimal. It's 5 or higher. Drop all this, increase the number in 1 by 1, you get 142 grams. And that's how you do it. And I'm going over this again because this is one of the most important skills in all general chemistry or chemistry, and is how to go from grams to moles, moles to grams, moles to atoms, and moles to grams. You should know. Now, before we leave the screen, you should still know how to use it. Let me just clean it up a little. Now, in the past, I would make students memorize this. But about a year and a half, almost 2 years ago, I came to the conclusion, am I testing your memory or am I testing your ability to do chemistry? And the answer is I'm testing your ability to do chemistry. So this will be part of test number 2, and I'll also put it on 3, that I will give you this information in the final 2, so you have to know how to use it, but you don't have to memorize the specific things on here. In the past, I used to do that. All right. Time to go over one of the most important of all concepts I know in chemistry. And this concept is extremely important. I've used it many times, and it's time for me to teach you it. Let's look at a balanced chemical equation. Let's make sure it's balanced. 4 hydrogens, 4 hydrogen, 2 oxygen, 2 oxygen. It's balanced. Now, it turns out the coefficients, the number in front of the formula, means something extremely important. All right, let me check. Everybody see it now? Let me check with my thumbs. Thank you. All right, let's go through this again. Here you have a balanced chemical equation. And we have 2 molecules of hydrogen, 1 molecule of oxygen, making 2 molecules of water. But the coefficients, the number in front, and when there's no number, you assume that's the number 1. Tell us something very important. And what is that? The coefficients in a balanced chemical equation give the numerical relationship among the formula units consumed or produced in a chemical equation. That's in your book. A better way of doing it, which I wrote and read, the coefficients in an equation, balanced chemical equation, give the fixed molar ratios between substances consumed or produced in a chemical reaction. Again, the coefficients give you molar ratios, fixed molar ratios. So what does that mean? I'll never ask you what does the coefficients mean, but I will ask you to know how to use that. What that means is for every 2 moles of hydrogen, you react 1 mole of oxygen to make 2 moles of water. The number in front tells you moles. 2 moles of hydrogen, 1 mole of oxygen make 2 moles of water. That relationship is probably one of the most powerful, important things I know in all of chemistry. Now, how do we use that? Let me clean this up a little. All right, let's go through this. 5 points. How many moles oxygen are needed to make 10.67 moles of water? Sometimes I'll also write how many moles of oxygen reacting with an excess of hydrogen. As soon as you see the word excess of something in a problem like this, that means you can ignore that molecule or atom. So the question is, how do we do this? Well, the first thing, as you've learned by now, what are we trying to find? Moles O2. What are we given? 10.67 moles of water. And how do we proceed? Oh, I can't resist. It's time again. Hold on, hang in there. It's time again to use your good buddy, your good friend, unit analysis. Like I said, I'm going for the Guinness Book of World Record. And now, let me check. Thumbs up, people. Can you see the screen with the thank you? Now you can still see it. I need a 32-inch monitor. All right. Now, we start with whatever we're given. And this is the only thing we're given. Actually not. You're also given a balanced chemical equation. But for now, let's look and use our good buddy, our good friend, unit analysis. What units do I want my answer to be? Moles of oxygen. And now we'll use our good buddy, our good friend, unit analysis. Whatever we're trying to get to goes on top of the ratio. Whatever we're trying to get rid of goes underneath the ratio. And therefore, I have on top moles oxygen. I have here moles of water. Where do I get those numbers? Well, the balanced chemical equation. Notice when there's no number, it's number 1. This tells us 1 mole of oxygen makes 2 moles of water. Remember the coefficients, the number in front of the balanced chemical equation tells us molar ratios. And this tells us 2 moles of hydrogen react with 1 mole of oxygen to make 2 moles of water. So now, since I know that, and you know that, I know for every 1 mole of oxygen, I make 2 moles of water. We get that from these numbers. Now, these numbers are exact numbers. Therefore, exact numbers do not play a role in the calculation. Notice this is 4 significant figures. Our answer should be 4 significant figures. And before I go ahead, I'm going to use unit analysis again to make sure I get the right units on my answer. Remember, anything divided by itself is number 1. Moles of water divided by moles of water become 1, cancel out, and I'm left with just moles of oxygen, which is what I want. And let me remember what I did. And it's time to go to my calculator. And the question is, how do you round this off to 4 significant figures? Well, it's an easy one. Keep the 5, keep the 3, keep the 3, keep the 5. Use the 0 to round off. It's 4 or less, so the answer is 5.335. And therefore, you have 5.335. Let's go through this again, because this is one of the most important concepts in all of chemistry, at least in my opinion. And here, remember, a balanced chemical equation gives you the fixed molar ratios. Therefore, this tells us 2 moles of hydrogen react with 1 mole. When there's no number in front of the molecule, it's the number 1. 1 mole of oxygen to make 2 moles of water. We're asked how many moles of oxygen are needed to make these many moles of water. This is what we're trying to find. This is what we're given. We use our good buddy, oh, I better do it again, our good friend, unit analysis. I won't charge extra for the whistle. But anyways, what I have to start with is right here. What I'm trying to get to unit-wise is right here. And if we can make that conversion using in one step a ratio, whatever units I'm trying to get to go on top of the ratio, whatever units I'm going to get rid of go underneath the ratio. Why underneath? Because anything divided by itself equals the number 1. And where do I get these numbers? From the balanced chemical equation. 1 mole of oxygen makes 2 moles of water. 1 mole oxygen, 2 moles of water. And therefore, I can do that. Remember, these numbers are exact. You can't have 2.5, 2 1/3, whatever. These are always exact whole numbers. Therefore, they do not play a role in your calculation to determine how many significant figures. In this case, this was the only one, and here we have that. Oh, this is fun. Let's do another one. Let's make sure this is balanced. 6 hydrogen, 6 hydrogen, 2 nitrogen, 2 nitrogen. And this is reaction of hydrogen gas and ammonia, nitrogen makes ammonia. It's a very important reaction. All right. Why don't you first try to figure out what are you being asked to find? What are you given? That's all you're supposed to do now. We're going to go a couple minutes past where I normally take a break. We'll still take our 5-minute break because Dr. White needs to stretch, and maybe you do too, or a refill for coffee, tea, or whatever. Not asking you to do the problem, just figure out what are you being asked to find, what are you given. I'll give you 4.8 seconds. 4, 4.2, 4.5, 4.6, 4.75. Time's up. All right, we're being asked to find how many moles of ammonia. What are we given? All right, we're also given the balanced chemical equation. Now, notice here I say excess of nitrogen. For this type of problem, as soon as you see that, you ignore it. Just ignore it. So now it's time to use your good buddy, your good friend. I think you had the whistle enough today. Unit analysis, and whatever I'm trying to start with, or whatever I have, is where I start. If I could have a magic ratio conversion, something over something, and multiply it from times what and divide what I have, what answer do I want unit-wise? And this is why you take the time to do this. Now, I'm going to let you have some fun. I'm just pulling a winky dink on you, and I also just pull the generation gap. Why don't you figure out what goes here and what goes here? Don't do the math, just figure out what should go there. All right, time's up. Put down your computer, hand it. No, I'm just kidding. All right, unit analysis, your good buddy, your good friend. Whatever units you're trying to get to, go on top. Whatever units you're trying to get rid of, go underneath. Therefore, I'm trying to get to moles, NH3. I'm trying to get rid of moles, hydrogen. Now, where do I get these numbers? I come up here and see the coefficients of a balanced chemical equation give you the molar ratios. And this tells you for every 3 moles of hydrogen, 1 mole, remember when there's no number in front, it's the number 1, react with 1 mole of nitrogen to make 2 moles of ammonia. Again, the coefficients of a balanced chemical equation tell you the molar ratios between your reactants and your product or products. 3 moles hydrogen, 1 mole nitrogen make 2 moles of ammonia. Therefore, 3 moles of hydrogen make 2 moles of ammonia. These are exact numbers. Notice I start with 4.66, and my answer, which 4.66 has 3 significant figures, my answer should have 3 significant figures. and here's the number I get. I'll let you round that off to 3 significant figures, then I will. Time's up. Put down your computer. No, you don't have to. 3 significant figures. Keep the 3, keep the 1, keep the 6, keep the 0. Jumped ahead of myself. Bad, Dr. White. Keep the 3, keep the 1, keep the 0. Use the 6 to round off. Is that 5 or higher? Yes. Past the decimal, all this gets dropped. This gets increased to 0 by 1 to 3.11. And that's how you do it. Let's quickly go again through this. You're asked to find what? How many moles of ammonia? You're given that you react 4.66 moles of hydrogen with an excess of nitrogen. Therefore, for this problem, we have this is what we have. We start with moles of hydrogen using an analysis. What answer do we want? Unit-wise, this. Whatever we're trying to get to goes on top of the ratio. Whatever we're trying to get rid of goes underneath, because anything divided by itself is 1. I didn't do this, so I'll do it now. This cancels out. We're left with the right units. Where do I get the numbers that go in here? I look up here and say for every 3 moles of hydrogen, I make 2 moles of ammonia. And you do the math, and that's what you get. And that's how you do it. And guess what? We did our practice time. We'll come back. Let's take a break now. Come back at, I'll give you an extra 30 seconds. Come back at 10 o'clock. That's when the big hand is on the 12. You know that. Or for those of you who have digital watches, 10, 0, semicolon, 0, 0. With that, I'll see you in about 5 minutes. I'm going to go do my stretching exercises. All right, let's get back to work. Let's do one more. And why don't you try this one all on your own? If you don't have a calculator, just set it up. And it is how many moles chlorine are needed to make 125.5 moles of sodium chloride. And I might have written also how many moles of chlorine with an excess of sodium are needed to make 125.5 moles of sodium chloride. Your turn. Have fun. And normally at this point, I'd be looking around the class, seeing if everybody's done. I'd say, when you're done, look up and smile. But I can't do that now because not all of you have your video on. And therefore, if you don't have your video, when you're done, give me a thumbs up. That's the thing on your button on your Zoom if you don't have video turned on. At this point, I tell my class, please be patient. I try and give everybody time to do this. All right, let's do it. So the question is, how many moles of chlorine are needed to make 125.5 moles of sodium chloride? First thing I always do, and it would help if you do it too, figure out what are you trying to find? Moles of chlorine. What are you given? This. And you're also given the balanced chemical equation. And let me quick check with my thumbs up, people. Can everybody see what I'm, thank you. All right, so it's time to use your good friend, your good buddy, unit analysis. This is all we have to start with. If I can multiply this times some magic ratio, what units do I want my answer to be? Ah. moles of chlorine. Now, here's where you use your good buddy, your good friend, unit analysis. Whatever units you're trying to get to, go on top of this ratio. Whatever units you're trying to get rid of, go underneath. And now if I look at this, this will be moles of chlorine, and this will be moles of sodium chloride. Don't forget to pass the NaCl, 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 table salt. And where do I get these numbers? I come over here and look at the balanced chemical equation. And this tells me 2 moles of sodium react when there's no number, it's the number 1 mole of chlorine to make 2 moles of sodium chloride. Again, 2 moles sodium react with 1 mole of chlorine to make 2 moles of sodium chloride. So 1 mole of chlorine makes 2 moles of sodium chloride. And that's where I get these numbers, from the balanced chemical equation, because the coefficients give me molar ratios. 2 moles sodium, 1 mole chlorine, 2 moles sodium chloride. These are exact numbers. Therefore, this is 4 significant figures. My answer should be 4 significant figures. And I'll go over to my calculator, but before I do, I'm going to check and use my good buddy unit analysis again. Remember, anything divided by itself becomes the number 1. Moles of sodium chloride divided by moles of sodium chloride cancel out. Make sure you check that. Just don't do this blindly. I have students get these reversed, and what you end up with, moles of sodium chloride times moles of sodium chloride divided by moles of chlorine, and immediately you know I made a mistake. If you did that, I didn't. So now I can pick up my calculator, because the only thing I'm left with unit-wise is what I want. And this is what I'm trying, this is my answer. Wow. It's twice in a row I have you round off number 0. And the correct answer would be, to 4 significant figures, 62.75 moles and that's your answer. Quick thing from Dr. White. On a problem like this, which is maybe 5 or 8 points, 6 or 8 points, show your work. Show this, show this, definitely show this. You don't have to. If you just put down the right answer, I'll give you full credit. But say you make a mistake, put in the wrong numbers in your calculator, and this is not the right answer that you put down, but if you show all your work, I would only take off 1 point, and I'd call it math error. If you put the wrong answer and don't show any work, I give you 0 points, because I don't know how you made a mistake. Now, in real life, you go into a lab or wherever, you won't find a balance, a scale that measures moles. I've never seen one, and I'm sure you never have. What do they measure for this class? Grams. Well, what do you do? Well, let's look at something. I see someone had a question. Well, not a question, the right answer. All right. There we go. I see where I made the mistake last time. I got myself confused. Let's look at the following. Balanced chemical equation, 4 hydrogens, 2 oxygen, 2 oxygen. Quick timeout commercial from Dr. White. Let's see, Wednesday, I'll do the practice problems, which I posted on, I think, Saturday or Sunday on Blackboard for chapter 6. It will be Wednesday. Thursday, I'll do the balanced chemical equations, chapter 7. What we're doing today, I'll do next Monday, the practice problems for that, chapter 8. Again, Wednesday, I'll do the chapter 6 practice problems. Thursday, I'll do the balanced chemical equations 7. And next Monday, we'll do what we're doing now. This way you have plenty of time because test number 2 is the hardest of all the tests we have this semester. And that's why I'm giving you extra time. Let's go back and look at a problem. If we look at this, the question is how many grams, because that's what you're going to find in real life, not moles, how many grams of oxygen are needed to make 61.5 grams of water? Well, I'm going to do what I've learned from Dr. White myself. I'm going to follow my own advice. What are we being asked to find? Grams of oxygen. What are we given? Oops. These many grams of water. And being a person who loves unit analysis, I'll say, well, let me start here. I want to get to grams of oxygen. I know whatever I'm trying to get to goes on top. Whatever I'm trying to get rid of goes under here. I look at this. Hold on. Oh, somebody beat me to it. All right. I look at this and I say, stop. Why? Because there's nowhere, no place I can find this ratio. Nowhere. There's nowhere I can find a relationship between grams of oxygen and grams of water. What do? Walk away from this? No. I go and look at the following. When you're doing mass calculations for reactions, finding out how many grams, you have to do 3 steps. You need the first, step number 1. Whatever you're given in weight, you have to convert to moles of that compound. We just did that. Step number 2, we did that actually last week. Step number 2, we did this morning. Whatever you now have moles of, you convert to moles of what you're trying to get. And finally, which we did last week, now the moles of what you're trying to get, you convert to grams of that. And remember, 1 mole of a molecule equals its molecular weight, and the molecular weight of Any compound is the sum of all atomic weights. On test number 2, I will actually give you this mass calculations. First step, whatever you have in grams, you convert to moles. Second step, moles of whatever you now have, you convert to moles of your answer. And third step, whatever you have moles of now, you convert to grams. Well, I better get to work. This won't work, so I'm getting rid of it. So we have to do 3 steps. And what do we mean by A? Whatever we're given weight. And notice the only thing we're given is this. So step 1, I have to go from 61.5 grams of water to moles of water. Why? Because the only relationship I have between what I'm starting with and what I'm trying to get is a molar relationship from the balanced chemical equation. 1 mole of oxygen makes 2 moles of water. So before I can use that relationship, I have to convert this A, in this case A is water, to moles. And now we'll use unit analysis. Whatever I'm trying to get to goes on top. Whatever I'm trying to get to goes underneath. Now I'll give this, but I'm writing it again. 1 mole of a compound equals the molecular weight of a compound in grams. Molecular weight is the sum of all atomic weights. We've already done the molecular weight of water. You can look back earlier today. And now notice grams of water. I'm left with moles of water. This is step 1. So now I go to my calculator. Hold on 1 second. And this is the number I have. Now, when you do calculations that are multi-step like this is going to be, there are 2 ways of dealing with significant figures. One philosophy is wait until the very end and do your significant figures. Another philosophy is do it each step, significant figures. I'm of the philosophy, do each step. Now, I'm not going to force you to do my philosophy on which is right. I've done the each step where I've done calculations where I'm dealing with about $250,000 in chemicals. Trust me, chemical companies fire you if you mess up and screw up $250,000, $250,000 in chemicals. Plus it costs more if you screw up. You also have to pay for the chemical company disposing of that mess you just made. So On a test, the answer, I will calculate both ways, and either answer is correct. Sometimes they're the same, sometimes they're different. But me personally, I'm a round off at each step guy. So what that means is when I do the calculations, this should be 3 significant figures. I can round off to 3.42. The way I have my cell set up, forget about the zeros, and I'll move on. So the first one is 3.42 moles of water. Now, are we done? No, because we're trying to get grams of oxygen. Now it's time for step number 2. Whatever we just calculated, in this case, A is water, we convert it to the moles of B, whatever we're trying to get to. So here I have 3.42 moles of water. What do I want to get to? Moles of B. In this case, B is what we're trying to get to, oxygen. And now I'll use my good buddy, my good friend. Yeah, I'm going to say this a lot. It's that important. Unit analysis, whatever I'm trying to get to, goes on top of the ratio. Whatever I'm trying to get rid of goes underneath. And where do I get these numbers? From the balanced chemical equation. For every 1 mole of oxygen, I make 2 moles of water. For every 1 mole of oxygen, I make 2 moles of water. So I know for every 1 mole of oxygen, I make 2 moles of water. And these are exact numbers. Therefore, I have 3 significant figures. I should end up, because I'm rounding off at each step. So now I'm going to go back to my calculator. Let's go back and look at this again. I'm going to divide this number by 2. Since I'm doing 2 separate paths, one round off at the end, one round off at each step, I now am here. So if I round this to 3 significant figures, I now have 1.71 moles. Of oxygen. Am I done? No. Why? Because I'm trying to get the grams of oxygen. So I've done step 1. I've done step 2. It's now time to do step 3. And don't forget, well, you don't have to forget. I'll show you. This will be given to you for test 2. We've done step 1. We've converted whatever we had to moles. We've gone from moles of A to moles of what we want our answer. Now we're going to do step 3, moles of B to grams of B. Mass means grams for this class. And now step 3. In this case, what's B? Oxygen. So I have this number. I want to get to grams of B, in this case, grams of oxygen. I'm going to do a winky dink on you, and I'll explain in a second what is winky dink. You figure out what units go on top, not the numbers, what units go underneath the ratio. Don't tell anybody. I'll give you 30 seconds. Go. All right, unit analysis. What I'm trying to get to goes on top. What I'm trying to get rid of goes underneath. And where do I get this number? 1 mole compound equals the molecular weight in grams of the compound. And therefore, I have 2 oxygen in O2. I think you all figured that. Each oxygen to 3 significant figures, and just so you don't have to memorize, but Dr. White knows this one by heart. To 3 significant figures is 16.0. I can do this one in my head. My first grade teacher would love me now. And that means 1 mole of oxygen is 32.0 grams of oxygen. Well, before we do this, I'm going to check my units. Remember, anything divided by itself equals the number 1. Moles divided by moles cancel out. I'm left with the right units. Now I can pick up my calculator. Now also, you see all this work? That's why it's worth 10 points. Plus this times 32.0 plus this times 32.0. Now, if I round this off, oh, this is unusual. It doesn't always happen. But if I round this one off to 3 significant figures, I get 54.7. And if I round this one off, which I rounded off at each step when I was doing the math, I get the same number. And what I mean by both ways is if you round it off at each step or at the end, in this case, you get the same, sometimes you don't. However, I'm a round off at each step person, and it's done me well. Like I said, I've done calculations worth lots and lots of money. Let's go through this again. I may go about a minute over, but hang in there, class. All right. How many grams of oxygen are needed to make this amount of water? Because there's no relationship between grams of oxygen, grams of water, even with the balanced chemical equation, I have to do this in for 3 steps. The first steps, I convert, and I've got this wrong. Yeah. Somebody should have caught me. Well, I told you the first day of class, I don't walk on water unless it's frozen even then. Well, anyways, you go from grams of whatever you're given to moles. And we've done this. Second step, the only relationship I have between oxygen and water from the balanced chemical equation is 1 mole of oxygen makes 2 moles of water. Therefore, I now have this amount of water. I want to convert this amount of moles. Moles goes on top using your good buddy, your good friend, unit analysis. Moles of water go here. Where do I get those numbers? From the balanced chemical equation. 1 mole of oxygen makes 2 moles of water. And I now have moles of oxygen, but I'm trying to get the grams of oxygen. and I'll do step 3. Moles of B goes to grams of B, and therefore I have moles of oxygen, want to get the grams of oxygen, and as you know, 1 mole of a compound equals the molecular weight in grams of the compound for oxygen. That's 2 times 16.0, 32.0. Put this here, because I know grams go on top, moles go here, and this is my final answer. And chemical plants throughout the world, when they make things you use in your daily life, and I've done those calculations, the soap you use, the fabric softener, the dye for this, my shirt, those are all made by using the 3 steps to do that. With that, I went a whole minute late. Sorry about that. It's time to say goodbye. Be healthy, gang gesund. I'll see you tomorrow. Be on time. Bye.